Okay, so tonight's topic. I got a bunch of stuff. There we go. All right, tonight's topic is a whole new section. I got to congratulate Key. She did really good. She got an A on her test over the first lesson. Way to go, Key! Pat yourself on the
Woo!
back.
I
We'll
did.
start a new section, and the next few videos and the next few lectures are going to be based on this, and it is linear equations. Linear equations in one variable. So we have a couple of things we need to define. I think maybe just one word. We know what variable is. We know what one is. So there's only going to be one variable. We know what an equation is. What's an equation? Let's remind everybody what an equation is.
A sentence that includes an equal sign.
Two algebraic expressions that are what? You already said
That are equal.
yeah, or I'm going to use a better word, equivalent. Another big word. Equivalent means equal to each other. Same. And that's one thing that we need to talk about in a minute is this word equivalent, because it's going to be used a lot in the next few lectures. Okay, so I guess the first thing we need to do is review some of the terms that we had. We had a solution. What was a solution of an equation?
Oh god. The number that x equals.
It's a value when substituted. It is the number that x equals, but I'm going to say it. Substituted. That's a big word. Into the variable results in what kind of equation? True.
Oh.
It's got to be true. So if there's variables on both sides, which we're going to get to eventually, maybe not today, but soon. So, and that's going to bring us to the word equivalent. Also another word that's often used is it's a value that, and I like this word too, satisfies the equation. Let's see if I can squeeze it out there. Satisfies the equation. Okay. Alright, so we've already gone over a variable. There's only going to be one variable in these. We already know what an equation is, so we need to discuss what this word linear is. Okay. Let's look at the word linear. And it literally is. What word sticks out mathematically to you in that word?
Line.
Subword line. Yeah, very good. These equations are lines. Okay. And they have one variable. So a linear equation and one variable. I'm just going to kind of list it off here. Has only one variable. Now the same variable can be used more than once, but there's not an x and a y. That would be two variables. There's only one variable. And no exponents. Okay? No exponents. So 3x plus 2 equals 5 is a linear equation. And these are the ones we're going to start. The simplest, but these are also the most common in math. More applications come out of these. So if you get through this chapter, you probably can solve more problems in math than you thought you could. Okay. So let's get more formal here with the formal definition. A linear equation in one variable is of the form ax plus b equals c, where a, b, and c are probably what? What kind of numbers?
Positive numbers?
They're
Real
real
numbers?
And, well, what number there will we not have an equation to solve? If you look at it, there's a value you can substitute from one of these, and then you wouldn't have an equation to solve. You would just have this.
What?
That's an equation.
Oh.
We wouldn't be able to solve nothing. So what has to be true about A? A can't be 0.
Oh.
If A is 0, then all you have is that, and then that's just is B equal to C. That's usually false. But okay.
Okay.
So it's of this form. This is what's important. Which is just like this form, right? This is the simplified form. Okay. So if we just say x, this is one that you could probably do in your head. That equation there, right? What is x?
1.
1. Okay, so each step we go by to solve these, we make equivalent equations. We say these two equations. Those are two different equations, right? This equation and this equation, they're different equations, but we call them equivalent equations. And equivalent equations have the same solution. So as we go down and solve these, each step is going to result in another equation that has the same solution. That's our goal.
Okay.
And there's ways to do it. It's not hard. Every step we go down, and this goes all the way up into quadratics, and God forbid if we do cubics. I don't think we're doing those in this chapter, but I mean this course, but maybe the next one. Okay. So that's any questions on what a linear equation in one variable is? Hey, what's up, Sophie? Any questions? Are you lost? Are you okay?
Me?
Yeah, I'm asking. Yeah, you're the only one
No,
I'm talking.
I'm good.
Okay, you're good. All right. Any questions out there in the
Twitchverse?
You can't say howdy no more. You live in Pennsylvania. Hi, Corinne. Corinne's watching too.
Hey, Corinne.
I don't like to call people out, but she's my friend. So, all right. So what we're going to use is what's called. This is part 2 of this little first section. We're going to use what's called the addition property of equality to solve equations. Okay? That's the first one. They're going to get into more later, but the first one is this one. Okay, so what we're going to do is we're going to find a number that we can add. The idea is to isolate the variable. What's isolate?
Did you just ask me a question?
Yes. What is isolate?
Get it by itself.
Get it by itself. Very good. That's our goal, and that's what the end of the equation is, right? X equals blank. Isolate it. Okay. And we're going to use the properties we learned in the previous chapter to do that here. We're going to use opposites, and then and later, we're going to use reciprocals. Okay?
Cool.
Make sense?
Yep.
Okay. So if I have the equation x minus 3 equals 8. Okay, I'm going to look for an equivalent equation. I want x by itself. X is going to be x plus what number? To make it by itself.
X plus minus x?
No.
Wait, what?
What number would I... Okay. Just think about this. What number do I add to x to get x? We learned about
0.
0. Okay. So my goal here is to make negative 3 0. How do I do that?
Oh, add 3.
Add 3. So the addition property of equality says if I add 3 to one side and I add 3 to the other side, I get the same equivalent equation. Okay?
Okay.
All right, so we're going to do that. We're going to have x minus 3 plus 3 is equal to 8 plus 3. So what's going to be left on this side?
X.
X. And then what's on this side?
11.
11. And we can go back and check our work. 11 minus 3 is 8.
Oh, okay.
Okay.
Cool.
So this is the addition property of equality. Property of, as I'm butchering this paper. Okay. If A is equal to B, okay, if A is equal to B, then A plus C has to be equal to B plus what?
C.
C. If I add the same number to both sides, I have an equivalent expression. This is kind of going backwards, but that's the whole goal here. Adding the same number, the whole point of this is adding, and when I say adding, I mean adding negatives to, subtracting. Adding the same number to both sides does not change the solution. Okay. All right. My turn, your turn.
Okay.
Okay. I already skipped one, but the one I skipped was pretty. Is this a linear equation? Yes or no? Now, here's a good question. Let me ask this one real quick. Before I start, I'm just going to ask you. Is the absolute value of x plus 2 equals to 5 a linear equation?
Wait, is... Yes.
Okay. Let me go back to the form of the linear equation. Linear equations look like this. Right?
Yeah.
So let me ask again. Does that look like this?
No.
No. So the answer is no.
Why, though?
Because this actually has two solutions.
Oh.
It's not linear. Because it makes two lines, actually. And we'll talk about absolute value equations much later. But that's
Okay.
day. What about 9 divided by x equals 13? Is that a linear equation?
No.
No. Very good. You're catching on. What about x minus 9 equals 13?
Yes.
All right. So you got these good. All right. You got that down pat. All right. Now you got it. If it looks hard, it's probably not linear.
Perfect.
Okay. And I mean that in the lightest of terms. If it looks If it looks like you got crazy symbols you've never seen yet that I haven't done an example of, it's probably not linear. Okay.
I
Gotcha. All right. I do one. You do one. Okay. We're going to solve, and then we're going to check. Solve and check. You can check in your head. You can say, yes, this minus this is this, or solve. Okay. Here's mine. X minus 5 equals 12. So I want 0 here. So if I add 5 to negative 5, it gives me X. But I added 5 to this side, so that means I have to add 5 to the other side. And the result is X equals 12 plus 5, which is 17. Let's check it. 17 minus 5 is indeed 12.
It sure is.
Alright, your turn. Oh, God. Yours is... I meant that about my next one. I give you an easy one, and I get a hard one. X minus 4 equals 19. Okay.
Okay, so I'm going to add 4 to both sides. So I get X equals 23, and 23 minus 4 is 19.
Right, okay, so you got rid of this negative by adding 4, filled it in, got 0 here. Alright.
Yep.
Here's mine. I'm being real nice here. I could have given this one to you. Z plus 2.8 is equal to 5.09. So to isolate Z, I'm going to subtract 2.8 from both sides. Well, I guess it's not too bad if I do it like this. It's not really minus 2.8. Alright. So that's going to give me Z over here. And over here, the 9 is going to come down. 10 minus 8 is 2, and we borrow, and we 2.29. So we'll check 2.29, and 2.8 does equal 5.09. Okay, yours looks a little different, but I think you can, if you think about it, I think you can get it. Okay? Don't freak out on me. Alright?
Let me add her.
Alright, here we go. 7 plus Z equals 11.
Okay.
So how do you get Z by itself?
So I'm gonna subtract 7 from each side.
Exactly. Very good. So we got 7 minus 7 plus 2.
So then we get Z equals 4.
Z equals 4.
So 7 plus 4 is indeed 11.
Very good. Could have done it better myself. Okay. I do these a little different. I want to show you a little trick that we haven't really done yet, but I'm going to jump the gun and show it to you anyway. Because fractions suck. Just so happens if you multiply the same number to both sides, you get the same equation. Okay. So here's mine. Solve. Oh well, can't really do that. I got to do it the hard way. Negative 1/2 is equal to x minus 3/4. Okay. That one's not too bad. Yours isn't that bad to subtract either, but okay. So if I add 3/4 to both sides, I get x. Even though x is over here, it's okay. It's still an equation, right?
Okay, yeah.
I mean, 2 equals x is the same as x equals 2. Okay?
Mm-hmm.
Kryn believes in you. You can do it.
Thanks, Gwen.
Okay, so we're going to add 3/4 to both sides. Right? We're going to say that's x minus 1/2 plus 3/4, and then x plus 3/4 minus 3/4. All right. That way it looks a little prettier. But I can add right there, right? That's 3/4 minus 1/2, right? This is
Yeah.
So it's 3/4 minus 2/4, which is 1/4. Right?
Yep.
Okay, so let's check it. Negative 1/2 equals 1/4 minus 3/4. Well, if I do that, this is equal to negative 2/4, right? One minus same denominator, and there's a 0.
Yep.
All right. Okay, your turn. T plus 5/6 is equal to negative 7/12. I want to become famous by it. No, I want you to go away.
What?
Yeah, ban somebody.
Oh, 6, dude. Alright, okay, so I'm gonna subtract 5, 6 from each side.
You advertising your crap. How do I delete that on here? How do I delete a message?
I got it.
Message deleted. How do I delete a message?
Alright,
Oh, thank
it's
you.
done.
Thanks, Key. You gotta show me how to do that. Fucker.
Alright.
Okay, so what do we subtract from both? Oh, wow. So 2 negatives make a positive. It's not going to be hard at all. Okay. 2 negatives don't make a positive. 2 negatives means you're bad.
Okay, yeah, so we're adding 5, 6 to the t side, but we're then adding negative.
So we're going to add.
Oh, wait, we're adding negative 5,
No,
6
we're not.
to.
We're taking it away.
Yeah, we're adding negative.
Yeah, we're adding
to
negative.
that
Okay.
side. And then on the other side, we are adding negative.
So negative 5, 6 minus 7.
10 over 12, basically. So minus 17 over 12.
Okay, so that's what we did right here, right? This is what's important because that isolates t.
Yeah, dude.
Okay, and that is going to equal 10, 6, and 7, 10 twelfths, right? Because if I multiply both of these.
Yeah, so it's minus or negative 17 over 12, which.
All right, that's reduced. 17 is what kind of
number? Prime number.
So we don't. Okay, so let's see. Negative 17 over 12 plus. We already know this is 10 over 12, right?
Yeah.
And 17 minus 10 is 7, and this number's bigger, so that's right.
Yeah.
Alright.
Sick.
Good job, good job. Okay, let's see what.
Thanks.
Okay, now we're gonna get a little bit. Oh. Okay, I didn't discuss these, but I will. Now it's time to change gears.
Thingsy, you can't sit here right now.
Alright. Sometimes you have to combine like terms before you can solve the equation. This mostly comes up in word problems. They look ugly, but when you write out a word problem and write out the situation, it might be something that looks like this. Here it is. 5y plus 3 minus 4y is equal to 6 plus 9. Okay. So this is a linear equation, right? Why is it a linear equation?
Because there is only one variable and there's no exponents.
That's yeah. Well, there's linear equations in 2 variables, but yeah, you
but it's the same variable.
It's the same variable, right? Why it's linear is there's no exponents. Okay, so we can combine these, and they're real nice to you. 5y minus 4y is y. So here we'll have 3 plus 5y minus 4y, which is y. And on this side, we'll have 6 plus 9, which is...
Wait, what?
6 plus
15.
9, 15, yeah. And then we solve this just like we did everything else. We take 3 from both sides. We'll have negative 3 plus y is equal to 15 minus 3. So y is equal to, and I'm probably off the screen. I'm sure y is equal to 12.
I'm getting close.
All right, so I'll check this just because I'm a nice guy. 5 times 12 is 60. Plus 3 minus 4 times 12, which is 48, has to equal 15. Okay. Yeah, 60 minus 48 is 12, and 12 plus 3 is 15. So it checks. Alright. Alright. Back to I do one, you do one.
Yay.
Yay! Don't get all excited. You did get all excited. Sarcastically excited.
I'm sorry. My head is just not, it's not my friend today.
Okay, I'm sorry.
And my stomach hurts too.
Could have said, we'll do it Saturday.
No, it's okay.
Alright, I do one, you do one. Anybody got any questions so far out in the audience? Any smart comments? I know you got those. Sophie, your my former partner's watching again. Okay, here we go. 8y plus 7 minus 7y minus 10 is equal to 6 plus 4. Okay, this is mine. Okay, so I'm going to combine all the like terms. 8 minus, if I combine these two, I get y, right? 8y's minus 7y's is y. With me?
Yep.
And 7 minus 10 is negative 3.
Mm-hmm.
Okay, and that is equal to 10.
Mm-hmm.
Okay, so to isolate y, we add 3 to both sides. So we'll have y minus 3 plus 3 is equal to 10 plus 3. And y is equal to 13. So 8 times 13. God, what is 8 times 13? 104? But if I take 104, if I take this two, if I take 8 13s and take away 7, I'm left with 113, right?
Yeah.
Okay, we could do that too. Plus 7 minus 10, which would be minus 3, right? That's minus 3.
Mm-hmm.
So that'd be 10 on this side and 10 on that side. Checks. Okay, your turn. Your turn is a little easier.
Good.
See, I'm being nice to Keeley.
Thanks.
Actually,
Appreciate
it
that.
just turns out that way. I'm not nice. Okay, 6y plus 3 minus 5y is equal to 14.
Okay, so 6y's minus 5y's equals y's plus 3 equals 14. So subtract 3 from each side to isolate y. And then we get y equals 11.
Okay, good. All right, so this is
then we
going
get...
Oh, you want it?
What?
It's 11.
Yeah.
All right, you
Okay.
don't have to check it.
Okay,
But
perfect.
like if you're taking the SAT class and they're like, "Hey, solve this," and it's multiple choice, and you can't solve it, just plug in the numbers and see if it makes a true statement, right? That's
Yeah.
That's kind of cheating. This is y plus 3 because 6y minus 5y is y, and then plus 3 carries down and 14 is by itself. Subtract 3 from both sides and we get y is equal to 11. Okay, sometimes, and this is where people struggle a little bit. Sometimes there are variables on both sides of the equation. Okay?
Ooh.
So, for example, 3x minus 6 is equal to 2x plus 5. Now, I want all the variables on one side of the equation. So if I take all the I always try to find the smallest one, or the biggest negative, the smallest number. In this case, it's 2x, right? The smallest coefficient. If I take 2 x's away from this side, that takes away all the x's from this side of the equation, right?
Yep.
But whatever I do to this side, what do I have to do to this side?
Yep.
The same thing, right?
It's the same. Oh,
So
yeah,
what's
the same thing.
left is x minus
Is
6
X.
is equal
Yeah.
to 5, right? And now we can easily solve it by adding 6 to both sides. And x is equal to 11. So 33 minus 6 is 27, and 22 and 5 is 27. So that checks. Okay. I won't throw you off guard on this one, Key. But I think you can handle it.
Alright.
I think you can handle it. Remember, you got to simplify everything first. That's the key.
Alright.
Cheer on, she can do it. Alright.
Woo.
The left side is 4x plus 2. But the right side is 3 times the difference of x and 6. Right? So what do you got to do? What do you got to use first? What is
The thing right.
What is that called? Distributive property.
Oh yeah, the distributive property.
Very good. God, you did that all by
Yeah. Yeah, it just came to me, and then I thought.
I'm gonna pin off Pimp. He said he was gonna come watch. All right. Go for it.
Okay,
So this is gonna stay by itself, right? Because it's simplified. Now what's the right
yeah,
side?
so for x plus 2, and then it'll be 3x minus 18 plus 8.
God, I can't even write as fast as you talk. All right, now what? This is simplified, but this is not.
Now I'm gonna take 3x from each side.
Oh, wait.
So I get.
What about this?
Oh, I guess I'll do negative 18 plus 8, which is negative 10.
Negative 10. Okay, now. What do we do?
So 3. Oh, so then we get x plus 2
Oh, yeah, take 3x from both sides.
equals negative 10.
X plus
And then.
2 is equal to negative 10. And now
Yeah, and then we subtract 2 from each side. So then we get negative 12 equals x.
I'll tell you what this, right. I wish I had a highlighter right now. I have a blue. This right here is the hardest part of the problem in most people's eyes.
What?
This is where people screw up the most. Hey, there he is. Speak of the devil. Start talking about it. Shows up.
Pimp.
All right.
What's up, other person?
Okay. Word problems. This is where you kind of struggled a little bit on the test, just a little bit.
I know.
One example. Okay. I'm gonna do one, and you're gonna do one, and yours is easier than mine.
Sick.
Word problems. And I'm not gonna write it all out. Something stupid. All right. Welcome to the stream.
Hopefully you get a little less stupid.
Okay. Well, that's their name. Something stupid. 1, 2, 3.
I know. It was a joke, Zarf. It was a joke.
There's a relationship between the number of words in a child's vocabulary. So there's a relationship. What does that mean? That means there's an equation. Between the child's vocabulary. The child's vocabulary is V. The child's age, which is A, in months. Okay. For ages 15 and 50 months. So listen up, pimp. This problem's for you. So there's a relationship between the vocabulary and the age and month for kids between 15 and 50 months. And here is the relationship. It is the vocabulary plus 900 is equal to 60A. So if you take the vocabulary and you add 900, the number of words they should know should be equal to 60 times the age in months.
Okay.
Find the vocabulary. So what's the vocabulary? What variable represents the vocabulary? V. Find the vocabulary when the child is 50 months. So what am I going to substitute?
You're going to substitute 50 for the A?
50 for A. So I'm going to do that. V plus 900 is equal to 60 times 50. Okay, so now I can simplify here, right?
Yeah.
And 50 times 60, it happens to be 3,000. So now, how do I solve for V?
Now you add 900 to each, or subtract 900 from each side.
We're going to do the opposite so we can get v by itself, which would be subtract 900. So we have v plus 900, and we take away 900. That should give us 3,000 minus 900. So we could say that the vocabulary at 50 months is 2,100 words.
Yes.
That changes after 50 months. It usually might go up, might go down. I don't know. Okay, not hard, right?
Not hard.
Okay, yours is an actual real-world formula, too. That was a real-world formula, but this one's even more real-world. But it's a lot simpler.
Realer world?
Real world.
Realer world.
What was that show? Real World?
Yeah. I didn't watch it, though.
I didn't have MTV, so. Okay, the cost. The cost of an item plus the markup is equal to the sales price. That's the formula. So that should make sense. How much something costs. The markup is the profit. If you add those up, that's how much they're going to sell it for, right? Am I on the screen?
Sure. No.
Oh, there. Now I'm on the screen, maybe.
Yeah, you are now.
So the cost plus the markup is equal to the sales price. So here's our question.
Yep.
For a particular computer, the selling price is $1,850. So it sells for $1,850.
Jeez.
That's the selling price. The markup is $150. The question is, what is the cost? How do we find the cost? I mean, I can do that in my head, but okay. That one's easy.
Okay, so you're just gonna. So the selling price is $1,850. The markup is $150. So you get C plus $150 equals $1,850 minus $150 from each side.
Mm-hmm. So we're taking away. This is what we're doing here. Is taking away. Where's my other card pen?
The cost is 1,700.
This is what we're doing to each side. 1,700. Right. So it cost the company $1,700. Okay. Now on a test, I would like that in a sentence. The cost is. Blank, blank,
Okay.
blank, blank. Which you did fine. You did it. You did that. So. Okay, that's the first section. You ready for more? Or you want to call it quits? 40 minutes in.
We can keep going for another section. I'm starting to feel a little bit better.
Okay, good. Math makes people feel better. Did you hear that?
Don't know.
All right. Moving on to the next section. So we use the additive property in this section. The next one, we're going to use the multiply property.
Yay.
And what do you multiply by? What is the multiplicative identity?
1.
1. So I want to multiply, if there's a term in front of there, I want to multiply by something so that I get 1x, which is like the answer, 1c, right? Kind of makes sense? This is 1c, right?
Yeah.
So we're going to do the same thing. The only difference is instead of adding both sides, we're going to multiply by both sides.
Okay.
Okay. Lies. Okay, I'm lost. I don't know what they're talking about.
About math making you feel better.
Oh. Yeah, you don't hear it. It made you feel better. It worked. All right. So here's the multiplication property of equality. Just like the added multiplication property.
Multiplication.
Multiplication property.
Multiplication.
Equality. Yeah, I'm gonna talk like a baby. Okay.
You wrote it down like that.
Well, you know I have a speech impediment, so give me a break. Multiplication property of equality Okay, so instead of A plus B,
Shit.
so if A equals B, then AC is equal to BC. Unless, what? Multiplication always has some kind of trick to it. Unless A or B is equal to 0. Okay. Oh. No, that works too. Never mind. It works if A is 0, because then it would be 0 equals 0, and then you can multiply. Okay, never mind. Forget that. Can't divide by 0, though, so gotta watch out for that. Alright, so the idea here is we're going to multiply by a number or divide by a number instead of using unless we have a fraction, and then we're going to use the reciprocal, right? So here's our first problem. I do it, you do it.
Okay.
Okay. Key's favorite part of the day. Makes you feel better.
Yeah.
Yeah. Okay. X divided by 3 is equal to 12. Is that linear?
No.
Yes, because X is in the denominator. So that's linear.
Oh.
Okay. So it is.
You mean X is in the numerator?
Yeah, X is in the numerator. Dyslexia.
Okay.
Where is the P, my dude? I don't know what you're talking about.
What?
He asked, where's the P, my dude?
In multiplication.
Oh, multiplication. Yeah.
Multiplication.
Oh, I can't. That's why I said it. Look how I spelt it.
I know. That's what I was making
Oh,
fun
I
of.
thought you were making fun of how I said
Completely
it.
missed it.
Okay. My degree's in math, not spelling. There.
I love that you just kept reading it like that too. It just didn't even think
What
anything
do I
of it.
multiply 1/3 by to get X? 1X. 3.
3.
Because 3 divided by 3 is 1X. Right? Because
Oh,
3
yeah,
times
that
X
makes
over 3
sense.
is equal to 3 over 3X.
Okay, so if X is in the denominator, then it's not a linear equation?
If X is in the denominator, it is not a linear equation. Yes.
Okay, I need to write that down. If
It is called a hyperbola if X is in the denominator, just so people want to know. If that was 3 over X equals 12, we would have a hyperbola. Which I'm sure everybody's so excited to learn. We'll get to hyperbolas one day. Hyperbolas are important in, gosh, like.
Okay, so we.
All right. So, but if I multiply by 3 here, what do I have to do over here?
Multiply by 3.
Right. So what's left on this side?
So then we get X equals 36.
Right. And we can go back and check. 36 divided by 3 is 12.
Yay!
Right, we did it. Your turn.
Ow.
Let me move it up. I can't see the bottom of the page. Okay, X over 5. X divided by 5 is equal to 6.
Alright. X divided by 5 equal to 6. Alright, so I'm gonna multiply by 5 on each side.
Mm-hmm.
So then I get X equals 30.
X equals 30. And you can check.
30 divided by 5 is 6. We're smart.
Alright, good. Good job.
We've done it.
You did it. Getting harder. So basically you do the inverse operation to both sides. Right?
Yeah.
Okay. Good. Okay, let's see. Line up the paper. Any questions over the problems that we just did in the chat room? Okay, I'm going to assume no. All right, here's mine. Negative 11y is equal to 44. So this is negative 11 times y. multiplication is the opposite of division, so we can divide both sides by 11. What happens when I divide both sides by negative 11? What do I get?
You get 0.
No. Don't get 0.
You get 1.
1, which is what I want, right? I want 1y. But then I have to divide this side by negative 11, and then I get y is equal to 4.
Yeah.
No, you get
Sure.
negative 4. Because that's positive divided by negative.
Oh.
Right?
Okay.
Watch your signs. Those killed Einstein. You know that?
What?
Signs. Einstein really was terrible at science. Okay.
Thank you.
Yours is a little trickier. Negative 28 is equal to 8z.
Negative 28 is equal to 8z. Okay. So, I guess I divide by 8
You do divide by 8 on both sides.
on both sides. So then I get... Oh my god, what is 28 divided by 8? I don't know this.
Z is equal to what? Negative 28 over 8.
Over 8, which can be reduced.
There you go. Both of those are divisible by what?
By 4.
4. What's 28 divided by 4?
Is it 7?
Yeah, negative 7. And 8 divided by 4 is...
Is 2, so negative 7 over 2.
And 7 over 2 is acceptable to me.
Cool.
Okay, my turn. If I have a fraction, let's say I have 4/5. What do I multiply 4/5 by to get 1?
5 over 4.
5 over 4. Okay, so if I have 2/3 of y is equal to 16. Okay. 2/3 of y is equal to 16. I'm going to multiply both sides by 3/2, right?
Yeah.
Okay.
Yep, for sure.
So I'm going to multiply this side by 3/2, and I'm going to multiply by this side by 3/2. Now, here's the hint. Always, if you can, divide. It's all multiply, right? This only works if it's all multiply. There's no plus or minus.
Yeah.
If you can, divide first, because the numbers will be smaller. Okay? So this
Okay.
side's going to be y, because 6 over 6 is 1.
Mm-hmm.
So I would divide 16 divided by 2. What's that give me?
8.
8. And 8 times 3 is 24.
Okay.
And 2/3 of 24 is equal to 16, which is what I started with.
Perfect.
Okay. Key's turn.
Yay.
There you go. Say it with some enthusiasm. Say it like you mean it.
Yay.
Yay!
Yay!
There you go. Yay! Get a yay out.
Yay.
Yay! All right. 28. I don't know. This book likes 28 today. Is equal to negative 7/2 x. The x does not have to be in parentheses. I just put it in parentheses.
Okay. Alright, so...
What am I going to multiply by? I want positive. I want this to be positive 1.
So you're gonna multiply by negative 2 over 7?
Excellent. So I multiply this by negative 2 over 7. So if I multiply this side by negative 2 over 7, what do I have to do to this side?
Multiply it by 2 over 7.
Negative 2 over 7.
So then...
Always try, it's all multiply, so we can divide first.
Yep, so then we get 2 times 4 equals 8.
Right. 28 divided by 7 is 4, and 4 times negative 2 is...
Negative 8.
Negatives kill people in the text.
Yeah, that would have killed me.
Negative 7/2 of 8, of negative 8, should give me 28, right?
Yeah.
Okay, so this negative times the negative is a positive. 8 divided by 2 is 4, and 4 times 7 is 28.
Mm-hmm.
Okay. Any questions in the realm? Okay. The next little section confuses a lot of people, but it is really
Oh,
not very
good.
hard. It's not very hard. Excuse me. In the next section, we're going to talk about our equations of the form negative x equals c. Okay, so I got this equation here. I want x equals something, right? What do I
Mm-hmm.
multiply negative 1 by to get positive 1?
-1.
Negative 1. So if negative x equals c, and I multiply both sides by negative 1, that means that x is equal to negative c. I want to say sometimes like move the negative over, but that's not always the case. Okay, so all right. But if you're in this form right here, you multiply by negative 1 or divide by negative 1. Either way, it works both ways. Because this negative x is the same as negative 1x. Okay.
Okay.
All right. All right. Here we go. You do it. I do it. I do it. You do it. I do it. You do it. You do it. I do it. I'll go first.
Okay.
Okay. There's 4 of these, but they're ridiculously easy. Okay. Negative x is equal to 5. If I multiply both sides by, I'm going to divide both sides by negative 1. That means that negative 1 divided by negative 1 is positive, and then 5 divided by negative 1 is negative 5. Okay. Here's yours. Negative x equals 17.
Okay. So divide by -1 on each side. So you literally just get x equals -17.
Very good. Good. My turn. Negative x equals negative 3. So I'm going to do the same thing. I'll divide both sides by negative 1. X is equal to, this is a negative divided by a negative, so it's positive. X equals 3. Okay. Yours has got a little bigger number in it, but I think you'll be able to handle it okay. Negative
Are you
47
sure?
equals negative y.
Alright. So I'm going to divide each side by -1. And then I literally get 47 equals y.
Y equals 47. Very good. Or 47 equals y. Means the same thing. Okay. Now we get to the fun ones.
Oh, yay. Did that sound genuine?
Yes. Yeah.
Okay.
No, it didn't. You gotta do a better job of
Damn.
that. Okay, so these equations we're going to solve the pure linear equation. Any questions over negative coefficients as an equation in the fish tank? I'll call y'all the fish tank, but okay. Here we go. We're going to solve equations of the form both. All right. We're going to solve it like this. I'm going to solve a general formula, but remember, all a, b, and c is equal to numbers, right? Except a can't be what?
0.
0. So the first thing we want to do when we see something like this, with 2 terms on both sides, this has 2 terms, and they're not
Yep.
like, right? I want to isolate the variable. Okay.
Okay.
So how do I get ax by itself?
You divide
No, I want.
by.
I
Wait.
want ax by itself.
Oh, you take b away from each
Right.
side.
You add. Yeah. You take b away from both sides. So we'll have ax plus b minus b is equal to c minus b. So that tells me that so the first thing we did was add or subtract. Okay. So then we'll have ax equals c minus b. And now how do we get x by itself?
Now we divide by A.
Divide by A. So if we divide by A, we get x equals c minus b over A. And this is a formula for the solution. But don't memorize this. Do it the long way. You're doing the same thing. When you do all this, you're doing this. You just don't realize it.
Yeah.
Okay. Okay. But again, if there's terms over here that can be simplified, or if there's variables on both sides of the equation, you got you want all the variables on one side, you want all the numbers on the other side. Same thing.
Okay.
Which is what we did here. We put all the numbers on one side. And
Yeah.
sometimes there's variables on both sides. We'll get to those in just a minute. Okay, here we go. I got something on my screen. All right, there we go. I do it, you do it. Negative 4y minus 15 is equal to 25. All right. So the first thing I want to do is I want to isolate this term. Everything's simplified. I can't simplify either side. So to isolate negative 4y, I'm going to add 15 to both sides. That would give me negative 4y plus 0, right? Right?
Yeah.
Okay. So we'll have negative 4y minus 15 plus 15. And it's important to point out that this is 0 is equal to 25, and I added 15 to both sides.
Mm-hmm.
Okay, so now I have negative 4y is equal to 40, right? 25 and 15 is 40.
Yep.
So now to isolate y, I divide both sides by 4. Negative 4. And y is now going to be negative 10, right?
Yes.
Okay, so if I plug in negative 10 here, negative 10 times negative 4 is 40. Right?
Yep.
40 minus 15 is 25. Checks. Okay. Always check your work. That's what's great about equations. You can always check your work by plugging it back in. Okay, I can't be any easier than this, Key.
Oh boy.
I can't. I can.
Okay.
2x plus 1 equals 11.
Oh wow. Okay.
See how nice I am? See how nice your host is tonight?
I appreciate that.
Random, but,
So I'm going
I'm being
to
nice, right?
subtract 1 from each side,
Okay.
and then I get 2x equals 10, and then I am going to divide by 2, so I get x equals 5.
And 10 plus 1 is 11. Check. All right. Easy. Any questions over that? Because
Why are you yelling at me?
they are about to get harder. Any questions over
good.
that? I'm asking the when I talk loud, I'm talking to the
Oh, I wasn't answering your question, so it's fine. Don't worry about it.
You still answer. I think you got it because you got the problem right. Okay.
Yeah.
Variables on both sides of the equation. Okay. I do it, you do it.
Cool.
As we kill trees over here at Mass Beast Tutoring. 2x minus 15, again we're on this negative 15 trip, is equal to negative 4x plus 21. Okay, so always do the variable first, and always find the smallest coefficient. Remember I said that earlier. When we have variables on both sides of the equation, find the smallest coefficient. Now here's the trick question. Which variable is the smallest coefficient?
2x? Oh, wait. No, negative 15.
What's a coefficient?
I don't
It's a
remember.
number in front of a variable.
Oh, okay. So, negative 4.
Negative 4.
X,
So,
actually.
to get rid of this and put it all over here, I'm going to do the opposite of subtract 4x. I'm going to add 4x.
Okay.
If you do that, then you're going to have positive numbers. That's why you find the smallest one, because nobody likes negative numbers. So now we're going to have 6x minus 15 excuse me, is equal to 21. Now, I want to isolate this because I can't simplify anything. So I'm going to add 15 to both sides. And 6x, right? Because 15 minus 15 is 0, leaves me with 6x is equal to 36. Yeah.
Yeah. Yeah.
Now what do I do?
Divide by 6.
Divide by 6. And x is
And you
equal to
get x equals
6. Okay, so 12 minus 15 is negative 3,
haunted.
right?
Uh-huh.
Does anybody see why that's 12 minus 15? I'm going quick to check these. And then negative 24 plus 21 is also negative 3. Checks.
Yeah.
All right, your turn. Okay.
Okay.
Okay. Oh, you're yawning. That's not good.
Ugh, that's math, dude.
Oh, jeez. Man. How'd you go on the positivity of the math? Now
It's not you, it's math.
it's not me, it's math. All right. 6x. Maybe this will wake you up. Plus 14 is equal to 2x minus 2.
Okay. Alright, so I am going to subtract 2x from each side.
Right, because 2 is the smallest coefficient. So
Yes. Which
that
gives
takes
me,
it. Oh, go ahead.
what, 4x plus 14 equals negative 2. Then I'm going to subtract 14 from each side, which gives me 4x equals negative 16.
Okay.
Then I'm gonna divide by 4, which gives me x equals negative 4.
Very good. Give Key a hand. Everybody give her a hand.
Thanks, France.
All right. Let's check it. Negative 4 times 6 is negative 24. Negative 24 and 14 is negative 10. Right?
Yeah.
Yeah? 6 times 4 is 24. But it's negative, so it's negative 24 and 14 is negative 10. And negative 2 times 2 times negative 4 is negative 8. Minus 2 is negative 10. So check it.
Negative
I'll
10.
check it real
Look
quick.
at us.
Key is smart. Key did real good on her
Oh,
test. She said Key is
thanks, France.
smart. What about me? Wait, and Josh is dumb.
I feel like my brain is jello right now, so I'm
Okay,
honestly kind of
word problems and we're
surprised.
done. One word problem.
Oh.
Actually, two. We'll do one. How about we just do one? Okay.
Alright.
All right. N. All right. This one's kind of confusing, but
Oh, yay.
yeah. Yours is cool. Mine's not cool. But Kemp might want to watch this. In 1980, the median. What is a median? Do you know what? Does anybody know what a median is?
Like the middle.
The middle. Very good. The median weekly earnings for men with a bachelor's degree or higher was $427 a week. Okay. In 2016, the medium early, I'm not going to write all this again, was 1,464. So people sat down and modeled this. It's modeled linearly, and we're going to learn how to do that later, but not yet. So if we model this, we get the formula M, which is the medium earning, is equal to 29N plus 427, where N is the number of years after 1980. So if I plugged in 0 here, look, I get 427, right? See?
Yeah.
That'd be 0 years after, okay? And that's 36 years. So if I plug in 36, somehow I get 1464. I'm not going to check that, but I'm pretty sure that's what happens. So the question is, my question is, It goes on. The question is, does the formula, now this is a formula, does the formula over or underestimate earnings in 2016? So we're actually going to find out. Okay, so this is the actual, this is the estimated. So what we're going to do is we're going to plug in 36 for n, right? 2016 is 2016 minus 1980 is 36. Okay. So m is equal to 29 times 36 plus 427. Okay. I'll do the multiplying. You can add, okay?
Thanks.
12 and 27 is 39, and 39 and 5 is 44. So it should be 1044. Wow. Whoa. No, that ain't right. That ain't right. I didn't add 427 yet. Okay. Right? And then when we add 427, we get, I actually have the answer in front of me and I did the multiply anyway. 4 and 7 is 1, carry a 1. 4 and 2 is 6, it's 7, and 1471. Okay, so this is what they calculated, and this is the actual. Does it overestimate or underestimate? Does this value overestimate or underestimate the actual value?
It overestimates the actual.
Very good. All right, here's the second problem. This is where we get into the real algebra part. The second part. If trends continue, how many, in what year will, there was a network error. Hope it's on that computer and not this one. In what year will the salary, the weekly salary of men with a bachelor's degree be 1,732? Okay, so we got the same formula. I'm going to rewrite it here. M equals 29N plus 427. So what do we know? What do we know in this equation?
So we know that M equals 1732.
Very good. Look what I'm going to have to divide by.
Nice.
29. See how yours is nothing like this. Plus 427. All right, so you help me solve it though. You tell me what to do and I'll do it. How about that?
Okay. So you're going to subtract 427 from each side.
Right. Okay, so we're going to subtract 427 from both sides. And that gives us 29n is equal to, this is 12 minus 7 is 5, and 2 minus 2 is 0, 14 minus
1305.
1305. So now I got to divide both sides by what?
29.
And if you think I'm going to do that in my head, I'm not a savant. Okay, well, 20 goes into 1/3, 30 goes into 124 times. I'm going to estimate about 4. Right. So 4 times 9 is 36. That's 116. How do I know that this number's good? How do I know that 4 is right?
Oh, because it's not over 29.
Very good. All right, now I'm going to divide 29 and 145. That one's easy. That's 5. So, is the answer 45?
No.
No. So the answer was what year? So what do I have to add 45 to?
1980.
So the average salary will be, according to the model, the average salary will be 1732 in 2025. Okay. Yours is actually a pretty cool problem, and I'll help you with it. As soon as I find the key. I think I lost the chat. Any questions over this word problem? Because this one's one more problem and we're done, Key. We did 2
Okay.
lessons tonight. We got
Yay!
pretty far. We got pretty far.
That was a genuine yay.
Oh, do you have the homework for chapter 2? Did I give that to you?
Yeah, I have it all,
I'll
dude.
give it all to you. Cheater.
It's all in a binder. Don't worry, I'm not looking at it.
Oh, I don't care. What's looking at it going to do to you?
I don't know. Why'd you just call me a cheater?
Because, I don't know, I was being funny. Okay, the mock. Anybody know what a mock is?
Something to do with the space or airplanes or something.
A mock is a speed. Okay, the mock is a measurement of speed, named after Ernest Mach. Okay, so the formula for Mach is M is equal to A divided by 740. And 740 is the speed of sound in miles per second. Miles per hour. So a Mach tells you how many times faster than the speed of sound you're flying at.
Sick.
Okay. Use the formula to determine the airspeed at Mach 2.03 in miles per hour, which A is given in miles per hour. So, what are we solving for?
For A.
We're solving for A, because here's your key. Determine the airspeed. So we're solving for A. So we're going to substitute 2.03 for M.
M.
Is that a linear equation?
Yes.
Yes, because A is in the numerator. All right, so how do we solve it?
You multiply each side by 740.
Multiply both sides by 740. Very good. All right. And I'm going to set this up as 740 times 2.03. Okay. So when we multiply this out, we get a 0 carried down. That's going to be 22, right? 3 times 4 is 12. Carry a 1. 3 times 7 is 20. Plus 1 is 22. Then we put 2 zeros because we're skipping this one, right?
Yep.
And 2 times 0 is 0. 2 times 4 is 8. And 7 times 2 is 14. We're going to add these up. So it's 0, 2, 2, 2 and 8 is 10. Carry a 1. But we got 2 decimal places here, so the answer is going to be right there. So the airspeed
is
miles per hour is 1,502.2. You don't have to put that 0 there. Yeah, at Mach 2.03. Okay. All right. So I think Key's worn out. That's going to do it for us tonight. Appreciate all the viewers, all the new viewers. Something stupid. Thanks for coming and watching. Pimp, always a pleasure.
Thanks, friends.
My buddy left. But that's okay. She was here too. Sophie, she's a traveling chick. Some number, I forgot the number. And then we got, of course, Kren. Check us out on Facebook, www.facebook.com/ not math space tutors, but math space tutoring. I can set up one-on-one tutoring sections in Discord, just like Key's doing right now. Key sees everything I do instantaneously in Discord as we chat, where you might have a little bit of delay. And we'll see you next Thursday, maybe. Work permitting.
Yeah.
at 9 p.m. Eastern Standard Time. And that's all we got. Oh, what's next? You want to know what's next?
What's next, dude?
What's next? That's a good question. What is the next topic? I don't have the book memorized. Okay, we're gonna formally solve. We're gonna do the same kind of equations, but we're gonna get more in depth with linear equations. We're gonna have linear equations with fractions, which we already did, but they're gonna be of the form, crazy stuff on both sides, distributive. We're gonna identify equations that don't have a solution, and that equations that have infinitely many solutions, and that will make instant sense once you see it. And then we're going to solve applied problems using formulas. And then after that, we're going to talk about formulas and percents, because we haven't talked anything about percent yet. So look forward to that next Thursday. I appreciate everybody coming out and watching. And if you want to go over to the Game and Josh show and watch that, that's what's coming up next on over on the other channel. And see you next week. AMF.
Bye.